Let's get started. I want to talk about the scientific method. Basically, when we're talking scientific method, I just really need to stress to you that what we're going to do today, we're not going to memorize, because the scientific method isn't like a hard and fast set of rules that always apply. It's very much a cycle, a process that scientists engage in, and they frequently do all the steps, but they're not always in this order. Sometimes some things are left out. So it's not like this perfect formula that we always follow, okay? It's like a general guidelines for how to conduct scientific investigation. I had a shocking thing that I've noticed in the 5 years that I've been in adult education classes. I noticed that 62% of our ABE students quit attending classes without achieving their goal. Now, most of you guys' goal is get your GED. This is an observation. This is something I noticed. We call that a phenomena. And this is a phenomena that I've noticed, and it's quite shocking to me, and I want to know why it's happening. And so, I'd go to these staff meetings, and everybody would have a different opinion. One of my coworkers would say, we need to change our teaching styles. Another one says, oh, it's those TABE tests, those starting tests the students have to take. They're too long, they scare students, so they never come back. We have a teacher who insists every time, no, the reason why our students don't continue is because it's always money. They have to end up going to work. They don't have money for a car, for transportation. They need financial support. If they had financial support, they'd finish. And then another one says, don't worry about it, Kate. It just follows the economy. Whenever the economy approves, we lose students because they go to work in jobs. And so everybody has a different opinion about this. So the question is, how am I supposed to know which one's right? We have this thing that I noticed. Everybody's got an opinion. And that is when we bring up the scientific method. We've got some ideas. We're noticing something happening. We want to know, what's really going on. That's the time for the scientific method. So let's take a look. Today we're just going to kind of do an overview of the scientific method, and then for the next 3 classes we're going to dive deep into some concepts that get really hairy on the GED, but today let's just do an overview. So first of all, I just want to stress to you guys that the scientific method, like I said, is a cycle. Yes, I have it numbered 1, 2, 3, 4, 5, but we can come in at different steps in the process and we can go backwards, and it's not like a perfect 1, 2, 3, 4, 5, okay? First step, observe, question, research. That is what you just saw me do. I made an observation. 62% of my students aren't finishing. What the heck? I'm questioning, why is this happening? And I'm doing some research. In that case, I was talking to my coworkers who'd been around longer than I have. What's going on with our students, okay? So observe, question, research. This is how generally scientists start out the process. Some people, when they teach the scientific method, will break this into 3 different steps, but it's all part of that same wondering process. The next step, and this one's super important to the GED, they love it, love it, love it. There will definitely be questions about this, is to form a hypothesis. This is the first word I brought up that you absolutely have to know for the GED. You have to know what I'm talking about when I say a hypothesis. We'll look at it a little bit deeper, but that is your idea. So now, after I've observed, I've questioned, I've researched, I am going to form my own hypothesis, my own prediction, my own guess as to what I think is happening with my students and why they're not achieving their goals. That would be my hypothesis. Once you've formed a hypothesis, you have some kind of prediction, you test it, and that's often called the experiment. Then you collect that data, that information we were talking about, and you analyze it. You look really closely at it to see, does it look like you were right or you weren't? And then you make a conclusion. Okay, so let's go ahead and look at each of those steps in more detail. Let's talk about the observing, questioning, and research portion. You should be looking around. We are observing or noticing phenomenon. A phenomenon is an occurrence. It's just something that's happening, but it's especially one that you notice again and again, so a repeated or habitual one. And it's especially one that's kind of mysterious to you. Usually when you guys have heard the word phenomenon, you've heard it in the context of ghosts or ESP, you know, that kind of stuff, the stuff we don't really understand. So yes, it does have this implication of it's mysterious. So that's that idea there. I had a phenomenon that you guys, 62% of students weren't achieving their goals, you know, so I'm going, that's mysterious. It keeps happening. I'm wondering about that phenomenon. And to let you guys know, one is a phenomenon, but the plural is not phenomenons, okay? The plural of that is phenomena. So if we have more than one phenomenon, that's phenomena. Then we start questioning, why is this happening? What could be causing or correlated with this phenomenon? Correlated is another word that shows up on the GED science test. So if you don't know it, you should take note of it. When two things are correlated, they occur together. Now, just talking to students who are going on to college, there's some math that goes along with correlation that doesn't necessarily apply on the GED, but anybody who's college bound is going to see it. They do what's called a correlation coefficient. So they make you find a number that tells you the strength of how strongly things are correlated. So some things are kind of like loosely correlated, loosely related. Like a great example is height and weight. Generally, as you get taller, you get heavier. But that's kind of a loose correlation because we all know tall, really thin people and shorter, heavier people. Like it's not a perfect correlation. But some things are perfectly correlated. Like talk about the number of hours you work and the money you make. Every time you work another hour, you make more money if you're an hourly employee. So that's a really strong correlation. So there's like different levels of correlation, how strongly things are related. But this idea that they're correlated means that they happen at the same time with some level of predictability. Then we want to do research. So we said we're going to observe, we're going to question, we're going to research. Hello, we are not trying to reinvent the wheel here. Okay, a lot of people, there's been a lot of programs for a lot of years teaching GED students. I am not the first GED teacher in the world. I should be getting online, looking at the research. What does it show? What have people already learned about GED students and them staying in school? Okay, scientists aren't trying to reinvent the wheel. They're building on each other's research. Okay, so that's the idea there of observing, questioning, and researching. So first basic step of the scientific method. This is the one that I said was one of the most important for the GED. Every single word on this thing is gold. If you haven't been paying attention to me so far because I talk too much, now's the time to tune in, y'all. Here it is. After they observe, they question, and they research, what do scientists do? They form a hypothesis. Now, remember what we said a hypothesis is. A lot of people will call a hypothesis an educated guess. I prefer to use a different word. It's an educated prediction. It's educated because I observed, questioned, and researched already. That's the educated part. So we already talked about that. But the prediction part, when you form a hypothesis, you are declaring that you think something is going to occur. So for example, if I was talking about my 62% of students, I could say students who are provided with financial supports such as childcare are more likely to persist in GED classes. Yeah, I just made a prediction. I'm saying if I give them childcare, you know, that's a huge financial burden for a lot of students, then they are going to come to class more often. I've made a prediction. I don't know if it's true yet, but it's a pretty darn good guess based on the research that I did. So I'm going to make some kind of a hypothesis. Notice that I narrowed it way down. I mean, there were a lot of big, broad things my coworkers were thinking about for the reasons that people didn't stay in school, but I brought it down to one little financial support. I said, if they have child care, they will stay. So look how specific that my hypothesis is. Don't be too general. That does not make for a strong hypothesis, okay? I really want to specifically identify two variables. What am I talking about, two variables? Well, I just told you that providing childcare was going to affect my students' retention rates. One thing affects the other, okay? Those are the two variables, and those two variables have a name, and we're going to be talking about it more in another class, but this is your first introduction to it. And if there's any favorite scientific method topic on the GED, it's this: identifying the independent versus the dependent variable, okay? So the independent variable is the thing that I think is doing the affecting. You know, when I was wondering, why are my students doing this? Why? That's the independent variable. I came along with they don't have childcare, that's what I settled on. So in this case, the independent variable is the childcare. It's the thing that I am going to manipulate. I'm going to either give them childcare or not give them childcare to see if it really does affect things. So the researcher manipulates that. Okay, then we have the dependent variable. That's that phenomenon, that thing we were wondering about in the first place, the thing that's happening that we were wondering about. It's that kind of what. So in this case, what is happening? Well, I'm talking about retention rates of my students, if they stay in class or not. This is the thing the researcher measures. I'm going to be measuring after I give them childcare or not, how much it affects my retention rates. So I'm going to be measuring my retention rates. Now, you guys, I cannot stress this enough, because one of the types of questions that happens on the GED is they'll ask you, like, which one of these could be the researcher's hypothesis. The hypothesis must make a prediction. So it is not a question. A lot of students, I'll say, write a hypothesis for me, and they write something like, will childcare improve retention? This is not a hypothesis. You have to commit, you guys. Right or wrong, you have to commit. You either have to say childcare will improve retention rates or it will not. Or, it's going to make them lower. You have to make some kind of a prediction. Okay, so questions will not work. So that's a super important thing. Do not use a question for a hypothesis. Okay, so here's an example of a hypothesis that had to do with me when I was working in the classroom. Sometimes students will do really well on tests and sometimes they won't. I thought, well, maybe it has to do with the temperature of the room. So my thought is, as the temperature of the room increases, test scores will decrease. Notice I'm making a prediction. I'm saying if this happens, then that will happen. And notice that there's two variables. We have that independent variable, we have the why the something is happening, and we have the dependent variable, the what's happening. We have this temperature. I think that temperature changing is affecting the other thing. So this is the independent variable. And what do I think that the temperature is affecting? I think it's affecting my students' test scores. So this is the dependent variable. It depends on the temperature. We will take a whole class where we practice just independent variables versus dependent variables, because it is such a struggle for students and it's all over the GED. It's their favorite. Two more things you need to know about the hypothesis. Two more vocab words that might come up. The hypothesis needs to be testable. Testable means that there is some experiment or investigation that we could conduct in order to test if our hypothesis. And I'm going to put holds true instead of is right, because the fact of the matter is the way hypotheses work is they test them again and again and again, and they keep refining them and testing them. Scientists don't tend to just say, oh, I'm right. They see if they can keep testing it and if it'll keep holding true every time they test it. So I could do that with my hypothesis about my GED students. I could perform a test, if I had more money, where I provide all my students with childcare and I see if retention rates go up. And then I would just measure. And if they really do go up, my hypothesis holds true. And if they don't go up, maybe I had the wrong idea. This is the word, though. Testable, usually students are good with. Falsifiable, you guys are not good with. So take special note of this one, okay? Because this is one students mix up a lot. Students think they see the word false, that falsifiable means their hypothesis is wrong. That's not what it means. It means that there is some outcome. Something could happen when you do your experiment, when you do your investigation, that could prove your hypothesis wrong. It doesn't mean it will, it just means it could. If I did that test and I gave them all childcare and my retention rates went down, or my retention rates weren't affected, that is a possible outcome. It might not happen. I don't know if it'll really happen, but it could. There is some possible outcome of my experiment that would prove me wrong. Basically, if you're going to conduct an experiment where no matter what happens, you're still right, you ain't doing science. Okay? I don't know what you're doing, but it ain't science. Okay, now comes the good part. We test our hypothesis. This is also often frequently called design and experiment. Your 7th grade science teachers made like experiments were the only way to test hypothesis. That's not true. Experiments are preferred because in an experiment where it's really, really controlled, you are just controlling your test so that the only thing you're testing is what we call independent variable. You're controlling for everything else, but not everything is possible to control. Like people are really hard to control. So it might not necessarily be like a scientific experiment. You might be just doing an investigation, a study, but very frequently on the GED test, they're going to talk about an experiment. But experiment, investigation, study, even surveys fall into here. These are all the ways that we can test a hypothesis. But surveys and studies occur a lot in psychology, but most often on the GED, we're going to see experiments being talked about. So let's talk about experiments. Okay. So like I said, an experiment is really, really controlled. When a scientist is doing an experiment, they are trying to pinpoint just one little aspect and see how big of an effect that has. The first way that they control it is that they'll have two groups. We'll have an experimental group and a control group. Your experimental group is the group that receives the independent variable. So we had said that my hypothesis was that students who get this independent variable of childcare will have improved retention rates. So my experimental group would be a group of students receiving the independent variable. It'd be a group of students who are getting childcare. But you need to have something to compare it to. It's not good science if you don't have a comparison. And so I would also need a control group. That would be a group that did not receive the independent variable. People like not getting the childcare. So I might give 100 students in our program childcare, 100 students don't get childcare. We compare, we collect data, and we're going to measure the dependent variable, in this case, the retention rates, and we'll compare. So basically the idea is when we're doing an experiment, which is a highly controlled investigation, we will have two different groups. In this case, since I'm testing students' behavior, we'd have a group of students in the experimental group. We'd have a group of students in the control group. The experimental group would get the independent variable. So in this case, childcare. Everybody here would get childcare. The control group gets no childcare. Then I collect the data. In this case, what's the data? What am I measuring? Well, I'm measuring retention rates. And I compare the retention rates of the two groups. Maybe this group, the childcare provided, they had a 62% retention rate, 62% of them finished classes, and maybe this one only had a 43% retention rate. 43% of them without childcare only finished their classes. And that would compare those two groups. So then let's talk about data, because there's two more vocab words you have to know. Dear Lord, there's a lot of vocab with the scientific method. So data, I said we're collecting data as we do our experiment. What does the word data mean? You know, we use it all the time, but what does it mean? Data is pieces of information. I mean, technically all information is data, but the scientists aren't going to collect all the information. You know, I'm in there conducting this experiment about my students with childcare, and there's tons and tons of data about my students that I probably won't take measure of, like their weight and their hair color. That's data, that's information, but I'm not going to collect it because it doesn't pertain to my experiment. So that's what we definitely need to know, qualitative versus quantitative. And for GED students who often struggle with reading, these two words look identical. Not all GED students, but a lot of them. Take a look at the beginning of the word, qualit, that one says, and this one says quanti. Kind of looks like the word quality and the word quantity. And indeed, they have those same roots. So let's talk about the word quantity in English first, because that's usually easier for students to understand. When you're talking about a quantity, you're talking about how much. This is a number. So data can be quantitative. It could be a number. You can collect numbers. So if I say my retention rates, that's a number. You know, 53% of students finished and got their GED. That's a number, 53%. Or I could count how many days they were there. The students were there 17 days into the semester. That's a number. It's quantitative data. But it's not the only kind of data there is. There's also qualitative data. So what's qualitative data? Well, that describes a quality. It's descriptive. It's in words. So in this case, it could be just you got childcare or no childcare. That's qualitative data. If I was doing an experiment about hair color, like maybe I think redheads are better at math, the hair color would be a piece of qualitative data. They're, you know, this person's a blonde, this person's a brunette. Qualitative data, it's describing words. So just two types of data. If they use those words, I need you to know what they're talking about. Now, the next thing that scientists do is they analyze the data, and I'm not going to get into this because we're not doing data analysis in this class. It's a whole class of its own because it gets so deep. But basically, data analysis is the branch of math that scientists and social scientists use. If any of you are going into the sciences or the social sciences, you are going to need to understand this math best of all. And what do they use it for? They use it to find patterns in data and make predictions. So they're going to literally predict the future based on what's happened in the past in their experiments. Charts and graphs are a huge one. They'll take that information, they'll organize it into a chart or graph, see if they can find patterns in it. Charts and graphs are big. They're all over the science, the social studies, and the math because of that. Another one, mean, median, mode, and range. Definitely all over the GED, super important. Very frequently, ratios and percents. I know you've heard statistics like 1 out of 3 people struggle with mental health issues, or 62% of students don't finish their GED. That's that idea. Ratios, percent, statistics come up very frequently. And another great example is probability. Remember we said we were going to predict the future? That's what probability does. It says what's the likelihood of something occurring again. So those are all examples of data analysis and all examples that are on the GED. Let's go ahead and look at the next step. Finally, scientists are going to reach a conclusion. But remember what I said, they are not going to say that they are right or wrong. They're not going to make that kind of commitment, y'all. It's just not going to happen because science is ever growing and developing and refining. It is such a refining process. They use a little bit looser language. Very frequently on the GED, you'll see something like the data supports the hypothesis. You know, what does it mean to support? It holds it up. It seems to hold true, but it's very qualified. It's like saying, I think my hypothesis is true. Based on this experiment, it still looks like it's true. This data has not proven me wrong, basically. But remember I said the scientific process was a cycle. Nothing is accepted in science from one little measly experiment. If this happens, scientists are not just going to leave it there like, oh, this must be right and we're all geniuses. They are going to continue retesting. They're going to see if other scientists can repeat the experiment and get the same results. Even though conclusion sounds final, this is not where it ends. So they make a conclusion based on that particular experiment, and then they keep testing to refine. Okay, so that's one possible conclusion. Another possible conclusion is that the data refutes the hypothesis. So this is when your data shows that your hypothesis is wrong. Scientists are much more comfortable with the hypothesis being wrong than declaring it's right. It's easy enough to say, oh, look, that data showed I was wrong. And if that's the case, then you know what you do? You reject that hypothesis, yes, but you get a new hypothesis. Reformulate your hypothesis, rewrite it, and then retest that one and keep testing. So, you know, even though we say this is the conclusion, the testing does not stop here. Whether your hypothesis seems to be right or seems to be wrong, we are going to keep testing, keep refining, keep building on the body of knowledge. It would take a lot of experimentation and a lot of research and results before scientists go, yeah, we're pretty sure this is right, we're going to move on. I just wanted you guys to know, what do you need for the test? They will test you on the vocabulary. It's one of the few things on the GED that you actually have to have the words memorized for. So the ones I underlined, independent variable, dependent variable, falsifiable, the words in the slideshow you should definitely know. Like we said, on the GED, they will ask you to identify the hypothesis, and Nicole pointed out you're going to be definitely identifying independent and dependent variables. They do test you on designing and improving experiments. There is data analysis, like I said, and then making conclusions based on data. They'll have you look at scientific data and then decide, does the data support or refute the hypothesis?
So I know that you didn't want to just watch this whole video only to not remember any of what you learned when it's test day. So remember, guys, they say that it takes 30 times for the average learner to practice something in order to have a memory of it on test day. So important that now that you've learned this, you go practice this skill. Check out the comments on YouTube or your Canvas class if you're in my virtual GED class, and find the practice, try the practice, make sure you remember this.